Uh, Very good morning, good afternoon and good evening to all of you and all the participants and students for this course. The title of the course is Multi-Criteria Decision Making, which is under the MOOC NPTEL course lectures. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as I generally start of the class with the broad outline what is the coverage and under which domain. So, actually we are covering the definitions, concept of utility theories, safety first principle, stochastic dominance, and this is the 13th lecture, which is we are in the third week. The coverage would be, as we are discussing the 4 different utility functions, the concept of quadratic, the concept of power utility function, the concept of logarithmic utility functions and the concept of exponential utility functions. We will cover them in details, then go into certainty equivalent, what we mean by certainty equivalent, then go into geometric mean, and this is the coverage we will do slowly do, and obviously updation would happen accordingly. So, first let us consider the case of quadratic utility function, and the formula given is this. If you remember, the quadratic utility function or quadratic functions generally we can consider as a x square plus b x plus c. So, here considering the utility function as w minus half of c w square. This half is just a constant in order to negate the 2 when you differentiate. So, if I find out u prime, so this will be 1 minus half c into 2 w. So, this is 1 minus c w, and if we consider u double prime, it comes out to be minus c. So, this is 1 minus half to c and u prime basically would become minus c. Now, if I consider the concept of a, the formula for a, if I use a was minus u double prime by u prime. So, minus sign remains, u double prime was c. So, minus minus becomes c, and in the denominator you have 1 minus c w. Now, you need to differentiate to find out a prime. So, a prime would be, c is a constant. So, it remains, and this 1 minus c w is in the denominator. So, when you differentiate it, it will become minus 1 minus c w whole square of a minus 2 obviously, because it will go into the denominator, multiplied by 1 minus c w, that is differentiation again. So, that will become minus c, which is again c square. So, if I see, it becomes c square by 1 minus c w whole square, and that is what the formula is. Now, here c is constant even if it is positive. So, even if it is negative, square of that will become a the positive term, denominator is a square. So, it is a positive term. So, it can easily be deduced that a prime would basically be greater than 0, which is increasing absolute risk aversion property. Now, if I take the value of r, so I will erase all these things, at least the green portion, this part also goes. So, if I use a different color for the calculation, so let me use a darker color, yes. So, now r is minus of w into u double prime by u prime, which is minus of w into u double prime is basically c. So, minus minus plus c plus 1 minus c w. I need to differentiate. So, differentiation is basically two functions. So, it will be the second function minus into the differentiation of first minus first function into differentiation of second, which will be plus c square, because minus and divided by square of the second. So, if I expand it, minus c w c square w plus c square w minus plus plus cancels. So, there is c here 1 minus c w whole square. So, this exactly matches the term which you have here. So, this is c being positive, you will basically, I will erase this part, c being positive and the denominator 1 minus c w square is also positive. So, obviously, you will have an increasing relative risk aversion property, which is r prime is greater than 0. So, quadratic utility functions with c positive has both increasing a and increasing r. So, how does the equations look like? So, I have tried drawing that using R programming. So, other diagrams also which you saw in the discussion all were built upon R programming also. So, if I consider the quadratic utility function with the value w minus half of c w square and c I am taking as plus 0.02. So, if I plot 1 by 1 u, next I plot a prime and third I plot r prime. So, along the x axis I have w as noted down here, and along the y axis I have all these three values of u, a prime, r prime drawn in the same graph scaling. So, that is why it will be difficult for us to understand now, but in the later graphs it will become clear. So, the utility function u would be like this decreasing, and a prime and r prime are shown here. They are not discernible, but they will become soon once we see them separately. So, if I draw them separately, all these three diagrams, they look like this. Again, utility the wealth is plotted along the x axis, utility only, it is not the three things, u, a prime and r prime are not being done together as in the last diagram, we are separately taking them. U is plotted along the y axis, and for the same quadratic utility function w minus half c w square with the c value, now with the c value of 0.002, because in order, because it is only c is only being multiplied by 10 to the power minus 2 here. In the other case it was 0.02, now I shift 2 places, so 0.02. So, that is just a scaling factor, but the characteristics of the graph remain same. So, if I plot and if I plot the diagram, so this is basically, I will use the color as given, this is the quadratic utility function, same type of characteristics as the last diagram here, downward sloping, this part, this is also same. If I continue doing them separately for a prime, r prime, the equations which we have derived. So, this is a prime here as shown, this one is a prime. For the quadratic utility function same thing and same value of c 0.002. The graph looks like this, and the value of w along being plotted along the x axis, w of a prime only, not 3 together on the y axis. So, this green line which you see here is basically the red part here, which is not discernible. It looks like a straight line, but actually if you zoom in, the graph would look like this for a prime. Finally, if I consider the r prime, so dr dw is r prime for the same utility function with c value 0.002, the graph is also similar to a prime, similar in characteristics, values may not be same, and again we plot w along the x axis, r prime w along the y axis, and this blue curve which you see here is the green one which almost look like a straight line. So, that is why I told that we are trying to draw them in the same graph paper and separately would give you a lot of more information. Now, let us come to the case of exponential utility function. The exponential utility function is given by minus e to the power minus a w, and remember a is positive. So, if I want to derive, I will use the red color for the first case. U prime is equal to minus minus plus e to the power, there is an a, e to the power minus a w, and u double prime is again minus a into a square e to the power minus a w. So, if I calculated a, which is minus u double prime by u prime, would be equal to minus minus plus. So, it becomes a square e to the power minus a w divided by u prime, which is again plus a e to the power minus a w. So, e to the power minus a w cancels from both numerator and denominator, a cancels from numerator and denominator, the value is a. So, when you differentiate a capital A, it becomes 0. So, hence it is constant absolute risk aversion property, and as given a prime is 0. So, now let us come to the fact of r. So, I will remove these green portions. The red portion, which is u prime and u, continues to be there because we will be utilizing that. So, let us use the different color. So, r is utilizing u prime and u is minus w u double prime by u prime becomes minus w u prime is minus minus plus a square e to the power minus a w by plus a e to the power minus a w. So, it becomes equal to e to the power minus a w cancels from both numerator and denominator, one value of a cancels from both numerator and denominator, the value becomes a w. So, if I differentiate r, it becomes a only, which is as given here, which is increasing relative risk aversion property, because r prime is equal to a constant. So, will be a constant value. So, is constant value in the sense a is positive. So, it is increasing. So, for this case, for exponential utility function, you have constant a and increasing r. Now, let us do the same thing when we plot. When we plot, the u prime curve is this, u curve which utility is this, and again the a prime and this is the u, a prime and r prime, they look almost straight line, they are not. we will see that later. W is given along the x axis and all the three values u, a prime are given along the y axis. By the way, for these graphs which I am drawing, there is a reason for that, because if you remember, for quadratic utility function the values of r prime and a prime were increasing. So, if they are increasing, obviously the graph should also replicate that, which you saw. We will again see that for all these utility functions, the second one being the exponential one. You have a prime here, almost a straight line, and you have r prime also a straight line, but we will differentiate that. And by the way, this utility function is minus e to the power minus a w, and the value chosen of a is plus, if you remember, it was positive. So, plus 0.01. Now, let us draw the curves. First is basically the utility function itself. So, again w along the x axis, only the utility along the y axis, and if I plot this minus e to the power minus a w with values of a is plus 1 here only, in order to, this is a scaling factor, does not matter. So, the equation looks like this. So, if I plot the values accordingly, and what are the values? So, I am plotting a prime here for the exponential utility function, which is minus e to the power minus a w with the value of a as plus 0.1. We are plotting w along the x axis and a prime along the y axis, and the graph looks like this, a straight line, if you remember, and the straight line is with value of 0. So, if you remember, we had derived as a prime as 0, and this is being very nicely replicated here. That is why I told that once you solve, if you draw the graph separately, it become easier for us to understand. For the next case, if you remember, r prime was a constant, a was constant. So, let us see whether it is replicated. So, again this is r prime, which is dr by dw for the exponential utility function minus e to the power minus a w with a value of a as 1. We are plotting w along the x axis and r w along the y axis, and very interestingly, there is again a straight line, but this straight line is not 0, because if you remember, the value of r prime was equal to a, and what is a? 0.1, which is multiplied here. So, the value of a which you see here and the value of a we started here actually corroborates the fact that the r prime calculations on the graphs are exactly the same. Let us go to the third example, which is basically the case where we are discussing the power utility function. Power utility function is c w to the power gamma, and c is less than 1, gamma is less than 1, this is the utility function. So, let us derive accordingly. U prime is equal to c gamma w to the power gamma minus 1, u double prime is equal to c gamma minus 1 w to the power gamma minus 2, and remember gamma is less than 1. So, let us derive a prime and r prime. So, we use a different color. So, now a is minus u double prime by u prime, which is minus c gamma minus 1 w to the power gamma minus 2 divided by u prime, which is c gamma w to the power gamma minus 1. So, c gamma cancels, minus c remains, minus gamma minus 1 remains, and here w to the power gamma minus 2 minus of gamma plus 1 basically will give you w to the power minus 1. So, if I differentiate, a prime becomes, this minus minus becomes 1. So, this is gamma minus 1 divided by w square, because it is w to the power minus 2. So, it comes down. So, this value exactly matches the decreasing absolute risk aversion property, which is a prime is less than 0. So, why I am saying decreasing? Because w is wealth, wealth is positive, even if it is consider any negative value, square is positive. So, 1 by w square is positive, gamma is less than 1. So, less than 1 value minus 1 will be negative. So, it is basically a prime is negative. So, this is corroborated. Now, let us erase it and do the problem for the case when we have the R factor. So, let us again use a different color. So, consider R is as per the formula minus W by U double prime into, sorry. So, this is, let us not get confused. Let us do the calculations correctly. So, it is W U double prime by U prime. So, it will become, it is minus, oh there is a minus sign, minus W C gamma W to the power gamma minus 1 divided by C gamma gamma minus, did I make a mistake? Oh, I should have taken the other way around. So, minus W C gamma gamma minus 1 W to the power minus 1 gamma minus 2 divided by U prime, which is C gamma W to the power gamma minus 1. Now, let us see, C gamma cancels. So, you have, and also very interestingly there is a W also. So, W to the power 1 into W to the gamma to the power minus 2 in the numerator gives me W to the power gamma minus 1. So, there is a W to the power gamma minus 1 on the denominator also, both of them cancel. So, the end result is, so basically it will be gamma minus 1 with the minus sign, because this cancels, these two cancel. So, it is minus gamma minus 1 minus. So, if I find out R prime, gamma minus 1 is a constant. So, it is 0. Now, if you see here, R prime is 0, which is constant R value. So, it corroborates the second fact also for the power utility function. Let us see the graphs. So, again all of them are three are plotted in the same graph first, which is U A prime R along the y axis, W on the x axis, and the graphs are given accordingly. So, this is the power utility function for a fact of C W to the power minus gamma with a C value of, if you remember, less than 1.9, gamma less than 1.3. So, U is plotted, and also is difficult to differentiate is basically A prime, which seems like a straight line, it would not, we will check it later, and again R prime, which seems to be a straight line, we will check it later. So, this is for R prime, this is for A prime, and we will corroborate that with the calculation just done. So, the first fact is only the utility function, which is the power utility function C W to the power gamma minus 1 with a C value of 0.9, gamma of 0.3, W being plotted along the x axis, only U being plotted along the y axis, and this is as the graph we have seen. Now, let us come to the other two derivatives, A prime and R prime. First, A prime. So, again w being plotted along the x axis, a prime being plotted along the y axis, and here you have dA dw which is a prime for the utility function which is c w to the power gamma with c value 0.9, gamma 0.3, both are less than 1. And if plot the curve is this. So, you remember it was not 0, and let us recollect the value was gamma minus 1 by w square as it is here. And if you plot derived it was r, it was a different value, we will see it later. If I plot the value of r prime for the utility function w to the power w c to the power w gamma with c as 0.9, gamma as 0.3, both less than 1, w being plotted along the x axis, r prime being plotted along the y axis, and interestingly this is a straight line. And if you remember, r prime was calculated because it was 0. Why? Because r value was minus gamma minus 1, gamma was constant. So, hence derivative was 0. So, it corroborates that. So, with this I will end this lecture and continue with the discussion with the last utility function discussion, which will be the logarithmic one. Have a nice day and thank you very much for your patience.